Welcome to my YouTube channel Modi Mechanical Engineering Tutorials. So in this video I would like to explain on MCQ on milling machines. So this is our session number 4. So first of all, subscribe my channel for the special kind of preparation onto the basic fundamental of mechanical engineering as well as the GAT, UPSC and all kind of government examinations. So let us start with our question number 1. Collect in milling machines are generally used to option A. Hold cutters, option B. Hold the workpiece on table, option C. Act as auxiliary spindle, option D. None of the mentions. So basically, collect in milling machines are generally used to hold the cutters. So the right answer is option A. The next question. Indexing head in milling machines are generally used to option A. Hold the cutters, option B. Hold the workpiece on table, option C. Act as auxiliary spindle, and option D. None of the mentions. Says into the first questions we already discussed, collect is used to hold the cutters. So in case of the indexing head in milling machines, which will be used to hold the workpiece onto the table. So by the application of indexing head, you will manufacturing a gear, because that will be used to dividing the periphery into equal number of parts. So that indexing head, it will be mounted onto the table, and that will be also hold the workpiece materials. So if you want to learn in details, so you will find a link in my description box. The next, which of the following is not a standard milling attachment? Option A. Arbors, option B. collets, option C. jigs and fixtures, and option D. adapters. So basically, arbors, collets and adapters, that will be the part of a standard milling attachment. So jigs and fixtures, that will be is not considering as a standard milling attachment. So basically, jigs and fixtures both are used to hold the workpiece materials, but the basic difference between jigs and fixture, jigs holds the workpiece and as well as providing the guidance to the tool during the operations, and fixtures, that will be only fix the workpiece materials, that will be not providing any guidance to the cutting tool. So if you want to learn in details between the basic difference between jigs and fixtures, so you will find a link in my description box. Then next question. Which of the following milling operations can be used for machining a flat surface parallel to the axis of the cutter? Option A. Slab milling, option B. Face milling, option C. Angular milling, and option D. Form milling. So just you can see, this is our cutter. These all are the cutting edges, and this is our workpiece materials. So just you can see the questions for making a flat surfaces. So here that will be the flat surfaces, and this surface which is parallel to the axis of the cutter. So this is the axis of the cutter. So both are the parallels. So this is the process of slab milling. So the right answer is A. Slab milling. So if you want to learn in details of the all kind of milling operations, so you will find a link in my description box. So in that case, that will be the face milling, angular millings and form millings, and the slab milling processes. Then we will discussing with the next question. Which of the following milling operation is used for irregular shapes? Option A, slab milling. Option B, face milling. Option C, angular milling. And option D, form milling. So as we already discussing for the slab milling, which is used to make of flat surfaces, and angular millings that will be used to make angular slots. So form milling cutter that will be used for making an irregular shape. So just you can see that this is our cutter. So if you want to make such kind of irregular shape, so you can use the form milling tool. So the right answer is option D. For more detail, you will find a link in my description box. Then, which of the following milling process is used for machining of two parallel vertical faces of the job simultaneously? Option A, keyway milling. Option B, groove milling. Option C, gang milling. And option D, straddle milling. So just you can see, so this is our tool and this is our workpiece material. So just you can see, this is our workpiece. So by the straddle milling cutter, you will make two parallel vertical faces onto the job. So these two parallel faces onto the job. So that will be called as a straddle milling process. And the tool is being called as a straddle milling cutter. So by the application of the straddle milling process, you should make two parallel vertical surfaces of the job. The next question. Which of the following operations can be used for parting of workpiece in two pieces? Option A, keyway milling. Option B, groove milling. Option C, saw milling. And option D, straddle milling. So basically option A, keyway milling, that will be used to make keyways. Groove milling, that will be used to make grooves onto the workpiece. And for straddle milling, that will be used to make two parallel vertical faces, as we already discussing. So the saw milling, that will be the operations can be used for parting of workpiece in two pieces. So the right answer is option C, saw milling process, or we can say operation is being performing. The next, in which of the following milling cutter power requirements will increasing slightly? Option A, negative rack angle tool. B, positive rack angle tool. Option C, both negative and positive rack angle tool. And option D, none of the mentions. So basically for the positive rack angle tool on milling cutters, that will be the power requirements will be increasing slightly. So the right answer is option B. Then next question. Diameter of milling cutter is 100 mm, running at 210 rpm. Cutting speed in meter per minute is equal to. So just you can see, V is equal to pi d n divided by 1000. So here that will be the diameter is 100 mm, rpm, that is the capital N, that will be 210. So you will get pi into 100 into 210 divided by 1000. So you will get around 66. So the right answer is C, 66 meter per minute. Then next question. In which of the following milling method chip thickness increase gradually? Option A, up milling. Option B, climb milling. option C, down milling, and option D, none of the mentions. So just you can see, so for the down milling process, at the initially that will be the maximum chip is being removed, and gradually that will be the decreasing into the at final stage. But for the up milling process, that will be initially that will be the minimum, but at the final that will be the maximum chip is being removed. So at the end of the up milling process, that will be the requirement of the larger amount of cutting force. So basically for the up milling process, initially that will be the small thickness of the chips, but gradually that will be the increasing. So the here question is, in which of the following milling method chip thickness increasing gradually? So this is for the up milling process. As initially that will be the minimum, at final that will be the maximum. So the right answer is in case of up milling process. So if you like this, then subscribe and share more mechanical engineering tutorials. Thank you so much and keep watching.